Today we're going to talk about some more word problems, cost and value, and mixture problems. So the cost and value tend to be a little bit easier. The mixture problems are sometimes the more challenging ones. So let's start with a couple cost and value problems. Number one says a collection of 60 dimes and nickels is worth $4.80. How many dimes and nickels are there? So usually for a cost and value problem, you're going to put down the side what we're talking about. We're talking about dimes and nickels and the number of each. Now, this is the tricky one, so we'll come back to this one. The value of the coin here. Now, you have to make a decision here if you want to put your values in cents or in dollars. And what I tend to do is to eliminate the decimals, I write them in cents. So a dime would be worth 10 cents, and a nickel would be worth 5 cents. Now you have to be careful later on when we start dealing with this $4.80 that we change that to all cents and not dollars and cents, so that will be 480 when we get to that point. Okay. Now we know that there are 60 total, 60 dimes and nickels, and here's where the tricky part comes from. If we know we have 60 coins, okay, let's say we knew there were 10 dimes. If we knew there were 10 dimes, how many nickels would there have to be? Well, if there's 60 total, we'd take 60 and subtract 10. And that would mean there'd be 50 nickels. Okay? Let's say we knew there were 23 dimes. If there were 23 dimes, we'd take 60 and subtract the number of dimes, and we would get the number of nickels that we have. Now here's the problem. We don't know how many dimes or nickels we have. So what we can do, instead of a value, an actual number for the dimes, we have X number of dimes. So now we just write an expression, 60 minus X. So if we're going to call dimes the variable X, and we know we have 60 total, then you're going to take the 60 and subtract the dimes, and that will leave you with the nickels. So we write an expression, 60 minus X. Okay? So anytime in any word problem when all you know is the total of something, and you can give one of them a variable and the other one the total minus that variable. So if you know a total like 60, then you call one of them X and one of them the total minus X. Now you have to make sure you use the total first. Otherwise, if you do X minus the total, you end up with a negative answer. You need to take the total 60, subtract the dimes, and be left with how many nickels you have. Now if we take the number of each coin times the value of each coin, multiply across, and that will give us the total value of all the dimes or the total value of all the nickels. So this is similar or the same exactly as the last word problem. So we multiply across, we get 10x. We multiply across here, and we have to remember to distribute. So we get 300 minus 5x. Distribute that 5 to the 60 and to the x. We know that it's worth $4.80 or 480 cents. So we want to add the total value of the dimes plus the total value of the nickels, and it should be equal to 480 cents. So if we're going no decimals here for the value of the coin, then we need no decimals here for the value of the dollars. So when we add down, we get 300. Now be careful here. 10x minus 5x gives us a positive 5x equals 480. Start solving. Undo your addition and subtraction. So 300, subtract that. We get 5x equals 180. Then divide by 5, and we get x equals 36. Once you know what x is, remember, go back up and fill it in everywhere you see an x in the chart. X is 36. 60 minus 36 would be 24. Okay. 10 times 36 would be 360. And 300 minus 5 times 36 will end up being 120. And you plug that in. 300 minus, and you do 5 times 36. And let's check. 360 plus 120 is 480, so we know that we did it right. And we have to make sure we go back and answer the question. How many dimes and nickels are there? There are 36 dimes and 24 nickels. Okay, what I would like you to do is pause here and try the second problem all by yourself. It is very much the same, and you can use the previous problem to help you with that one. Please pause here. All right, let's see how you did on this. Now we still know the value of a nickel is 5 cents. The value of a dime is 10 cents. We have a collection of 54 total. Now the question here is how many nickels are there? So you probably want to call the nickels X. Hopefully you did call the nickels X. Now if you didn't call it X, it doesn't matter. You can still get it all right if you called the dimes X. Now if you're going to call the nickels X because the question is asking about how many nickels, here in the previous question it said how many dimes and nickels, so you could have picked the variable for either of them. But if we know what we were looking for, how many nickels are there, then generally I call that one the variable. Now if we know we have 54 total, then this should be 54 minus X. The number of each coin, type of coin, times the value of each coin. We multiply across to get the total value. X times 5 is 5X. Distribute here, which gives us 540 minus 10X. The total value is $3.80, which is, remember, change it to cents would be 380 cents. We add down, the 540 is the constant, 5x minus 10x. Be very careful here. 5x minus 10x would be negative 5x. And then we start solving. Subtract 540. And we are going to get a negative, which is fine because we have a negative 5x here. So we get negative 160 here. When we divide both sides by a negative 5, we get x equals 32. Now, let's head back up here. X is 32, so that's going to make that 32. 54 minus 32 is 22. If we multiply here, 5 times 32, we get 160. And we get 54 minus 10 times 32. So basically 54 minus 320 is going to give you 220. So when we add down, we get 380. It does work. So let's answer the question. How many nickels are there? Number of nickels is 32. There are 32 nickels. Good. How did you do? Did you get it right? Now, again, you could call the dimes X and the nickels 54 minus X, and all of this still works. It won't look exactly the same here and here, but when you find your X here, which in this, if you did it the other way, you'd get X equals 22. When you plug X back in, you still get the nickels to be 32, the dimes to be 22, 160, and 220. So all of the values come out to be correct whether you use the X for the nickels or the X for the dimes. Just rule of thumb for me, if they're asking you how many nickels there are, then I usually call that one. And sometimes I use N for that. So those are your cost and value problems. The biggest thing you need to be careful of is the decimals. If you decide you're going to use 0.05 and 0.10 and you're going to keep the decimals, then you can use 3.8. But I really think this is probably the easier way to do this. There are less mistakes dealing with the decimals. Now, speaking of decimals, when you're doing a cost and mixture problem, we often will have to work with a decimal because we're dealing with percentages. So we're mixing things together. It says a chemistry experiment calls for 30% solution of copper sulfate. Kendra has 40 milliliters of a 25% solution, and she needs to mix it with a 60% solution. How many milliliters of that 60% solution should she add to obtain the 30% solution? So we're trying to get a 30% solution, and that's important. When you're doing a solution problem or a mixture problem, you want the two that you're mixing together to be here in these top two. And then the final mixture will always be in the bottom here. So in all the other word problems and chart problems that we've done, the two here can be mixed around. It makes no difference. And that's still true. These two can be flip-flopped here when we get to that. But your final mixture should always be here. So if we're trying to get a 30% solution, then our final mixture we want to be a 30% solution. The other two you can just fill in here. Kendra has a 40 milliliters of a 25% solution and a 60% solution. So she's mixing the 25, the low percentage solution, with the high percentage solution to try to get a medium percentage solution. And your final will always have to be that medium solution also. So there's another trick for you. So that's always going to be your final, and that's always going to be the middle value of the percentages. The high and the low will be mixed together to get that middle value. Now, because we're dealing with percentages, we can designate a column for changing that decimal or that percentage to a decimal. So 25%, remember we just moved the decimal twice to the left, so we get 0.25, 0.60, and 0.30. Move the decimal 2 places to the left. The amount of each solution. We know it says Kendra has 40 milliliters of the 25% solution. So we know she has 40 milliliters here. Okay. And we know that's all we know actually. The question is how many milliliters of the 60% solution should we add? So the 60% solution is the big question. So that's what we're really looking for. So that's going to be X. Now what you need to keep in mind is that what we're doing is we're mixing these two together to get the final solution. So we have to pour this one in, then pour this one in, mix them together. That'll give us our final solution. So when we're talking about the amounts of the solution, if this is 40 milliliters and we add some unknown amount of milliliters, then the final would be what we get when we add these two together, 40 plus X milliliters. All right, so that's how you fill that in. The one we're looking for is going to be your X. You often know 1, and then we would add those two together. There's one other possibility, which I think I'll show you on the next one. But when one of the ones you're mixing together is the unknown, you just add those two together to get this one. Now, just like any other word problem or chart problem, we multiply across. 0.25 times 40 is 0.10. 0.60 times x is 0.60x, or 0.6x if you want. Here we have to distribute. 0.30 times 40 actually gives us 12. And 0.30 times x would be 0.30x, or you can get rid of any of these zeros, remember. Now, that is the first difference. We've got 3 rows in a mixture problem, the two you're mixing together and the total. So there isn't going to be any information about what the total is besides we know that we're getting a 30% solution. So in a mixture problem, this always becomes your equation right here. When you add these two together, you'll always get this. So you just change this vertical equation into a horizontal equation. 0.10 plus 0.60x equals 12 plus 0.30x. So this is always a vertical equation. We're adding the first two together to get the third one, and then we need to solve it. You just have to be very careful with your decimals here. So we're going to subtract. We need to get all the x's together, and we want to work on moving the smaller one. So we're going to subtract this 0.30x minus 0.30x, and that gives us 0.10 plus 0.6 minus 0.3 would give us 0.3. and that leaves us with 12. Now we need to move this 0.10 over, so we subtract 0.10 minus 0.10, and we get 0.3x equals 12 minus 0.10, which should be 11.9. Now when we take 11.9 and divide it by 0.3, we get, um, 39 2/3. Or 39.7. Okay, let's see what happens here. So when we plug this back in, if x is 39.7, this would be 39.7. This would be 40 plus 39.7, which would be 79.7. This is still 0.10. 0.60 gives us 23.8. And if we do when we multiply that out, we get 23.9. Now, if we check this out here, 0.10 plus 23.8 will give us 23.9. So we go back and check this. The question is, how many milliliters of the 60% solution should she add to obtain the 30% solution? So how much of the 60% solution? She needs to add 39.7 milliliters of the 60% solution. Tough stuff. All right. So the high and the low go here. The final is always the medium. Write them as decimals. Figure out your amounts. Multiply across. This will always become your equation. Add these two together to get this one. And then you can write your equation and solve it. Let's try one more on the back. And this one throws in a pure, and we'll talk about that. So it says, how many quarts of pure orange juice should Mary add to a 10% orange juice drink to create 6 quarts of a 40% OJ? Okay. Now, again, you're going to mix the low and the high here to get the medium. All right. Now, we want to create 6 quarts of a 40% solution. So that's what we want to create. That's what we want our final to be, a 40% solution. What does pure mean? If it's pure orange juice, what percentage would that be? Pure orange juice would be 100%. So we want to mix a 100% with a 10% to get this 40%. So here's your high, here's your low. We'll mix a high and a low to get a medium, always. A medium's always got to be the final because you can't mix a high and a medium to get a low. You can't mix a medium and a low to get a high. You've got to mix the high and the low to get a medium. Change those to percentages, which makes this 1 because we move the decimal twice to the left. This is 0.1 and 0.4. amount of solution. Now here's where this one is different from the previous problem. We want to create 6 quarts. So this time we know for our final amount we want 6 quarts, and that's all we know. Now this is similar to the dimes and nickels. If we knew that we had 54 dimes and nickels, then we called one of them X, and the other one was the total minus X. So anytime all you know is the total, then you will do exactly that. The total in this case actually does fit in the chart for the cost of mixture problems. And then you pick a variable. Now we want to know how many quarts of pure orange juice you should add. So the pure, the 100%, that's the big question. That's what we really want to find. So generally we call that X because that's our major unknown. If that one's going to be X and we need a total of 6 quarts, then this would be the total minus X. So here's where you can get different. If you know one of these and then this is your unknown, you add them to get this one. If you know a total, a final product, then you call one of them X and the total minus X. So that can change depending on what the question says. Multiply across and we get 1x or just X. Here we get 0.6 minus 0.1x, and down here we get 2.4. So again, this is always going to be your equation. We add these two amounts together and set it equal to this one. So that, I guess, is one of the easy pieces in a question or in a mixture problem, because you always know where the equation is coming from. It's always going to be right here. Everything's in there. So we need to solve this. Combine your x's together. X minus 0.1x. That, you have to remember, is 1x minus 0.1x. So that's going to be 0.9x. That's $1 minus 10 cents. 0.9x. At the same time, I guess, I'm going to move this 0.6 over. So subtract 0.6, subtract 0.6. So you can subtract and combine those at the same time. 2.4 minus 0.6 is 1.8. Then we divide both sides by 0.9, and we get x equals 2. That's a nice pretty number, so let's go plug that back in and see what happens. X is 2. 6 minus 2 would be 4. Here we've got 1x, which would be 2. Then this would be 0.6 minus 0.2, which would be 0.4. Now, when we add the 2 plus 4 together, it does give us 6, so that checks out there. And 2 plus 0.4 does give us 2.4. So both spots check out. Let's answer the question. How many quarts of pure orange juice should Mary add? Pure, this one's the pure, 100%. How many quarts? 2 quarts. Mary should add, add 2 quarts of pure OJ. All right, now these are more challenging chart problems, so I'm sure you'll have to go back and rewind and watch them again over and over if you'd like, as often as you need it. And you can also ask me questions, but enjoy. I hope that you aren't totally confused, but if you are, like I said, just watch them again.